Right, so now we're looking at a frequency polygon. The table shows information of daily rainfall in the town for 60 days. Draw a frequency polygon. Our frequency polygon is a bit like a bar chart and a bit like a line graph that will sort of explain what's going on. Now I'm going to put a point somewhere that sums up this class, this category between 0 and 5. So I could pick 0, I could pick 5, but a sensible thing to pick probably would be in the middle of those two values. So I'm going to plot everything there at 2.5. Here between 5 and 10 I'm going to go halfway again. So I always try and use the middle of these categories, except for cumulative frequency, which is annoying. But I'm going to use the middle of the category. So I'm going to say that when the rainfall is 2.5, there is a frequency of 8. And I'm going to say when the rainfall is 7.5, the frequency is 24. And I'm going to say when the rainfall is 12.5, the frequency is 13. When the rainfall is 17.5, the frequency is 11. And when the rainfall is 22.5, the frequency is 4. So I've just gone the midpoint of the class interval. And then I'm going to join them all together because a polygon is joined together with straight lines. And that's what our frequency polygon looks like. Right, this one. This was probably the most annoying question when I was marking it, because loads of people made silly mistakes on it. Right, so odd numbers. I'm going to write down all my odd numbers up here because I think it probably helps me fill in this diagram. Square numbers. I've got 1 times 1, I've got 2 times 2, and I've got 3 times 3. Anything bigger than that doesn't fit into our Venn diagram. So firstly, I'm looking at this, right, what numbers are in both of these categories? Well, 1 is a square number and it's an odd number, so 1's going to go in the middle. So is 9, it's a square number and it's an odd number, so 9's going to go in there. What numbers are left on this side? In group B, the only thing that's left is number 4, so 4's going to go there. What's left on this side? 3 and a 5 and a 7. So this is looking good. Now let's just double check I've done it right. Well, I've used the number 1, that's correct. Oh, hold on, 2's not gone anywhere. 3, I've used 3, I've used 4, I've used 5, I've not used 6, I've used 7, not used 8, used 9, and used 10. So the sections I've drawn so far are correct, but I still need to finish off by using all of the numbers. So those numbers that aren't in A and aren't in B have just got to go on the outside of the two sets. And this one, find the property that is, so B with a little dash, so that means the complement of B, but that means not in B. So it says find the probability that this number is not in set B. Well, look, how many values are inside here? Well, there's 10 values inside here. So I've got a denominator of 10. Now, all of these ones here are in B. So all of those ones there are in B. So they're in B and they're in B. So how many of them are not shaded in? 1, 2, 3, 4, 5, 6, 7. So 7 out of 10. 5 marks. Quite a nice question for 5 marks, I think.